Hello and welcome to my video on my AI module game. I first started with the A-Star Pathfinding and Grid Lab and made the grid 3D so my AIs could walk up and down in the y-axis. I then edited how the nodes of the grid are decided to be walkable or non-walkable, as there were walkable nodes in the sky. I did this by sending a raycast down to see if there was a solid object beneath the node, within a range. The Pathfinder uses A-Star and uses Euclidean distance, and uses a heap optimization, although the heap optimization was done later on in development. The move function in Pathfinder has it so the AI slowly rotates to where it's heading, and it also has wall detection. This is so AIs don't get stuck on corners, and was done later on in development. Next, I started on the Rat FSM, which uses a stack to control what state it should be in. The Rat FSM and all other AIs use a script called sensors, which controls which sensors it's using and the settings for those sensors. The rat uses ray bundles as a way to see in the shape of a half cone. The rays are then drawn as gizmos. The rat also uses overlap sphere to smell and hear. It also stores this information and displays it using gizmos. The logic behind the rat is built according to how I planned it. The wander state uses a function in the grid script that gets a random place to go within 10 nodes, then heads to it. It pops the state once it reaches the location. FleePath uses a function in Pathfinder that finds a path using A-Star. However, it works by rewarding the Pathfinder to walk in the opposite direction of the goal, and then it caps the loops it does to 15, so it does not pathfind forever. Flee lasts for 5 seconds. Seek state uses a function from the Pathfinder that finds a path and returns its distance, but does not save the path. This is used to compare distance of the objects it sees to figure out which ones it needs to follow. It then pathfinds and follows to the location of the target, and uses another function that moves the AI closer to the actual location. Attack state sets an active, a child object that has a script that deals damage on overlap. All AIs have the same script. All that changes is what it can hit. Rest state does nothing for 3 seconds, and then resets tiredness. Dead state does nothing for 10 seconds, then respawns rat. I then started on my GOAP AI called Monster. The GOAP system I used was built off the one from the lab. The GOAP, when it plans, gets all possible list of actions that it can use to get to the goal, and then uses the cheapest way to get to the goal. I first added a system where the cost of an action is updated every time a plan is made, by running a function called updateCost. By default it does nothing, but for certain actions, in which the cost needs to be updated, it is overwritten and updates the cost. The actions that use this are all the follow actions, and they all change the cost to 1 plus the distance of the specific target they are for. These actions, and the here action, also overwrites the isAchievable function, so that they only return true if they see or hear the things they need to do. The monster sees in the same way the rat sees. The only change is that it can see the rats as well. And the hearing also uses overlap sphere like the rat. The monster has 3 goals that can be added or deleted. They are eat, find food, and get to safety. Get to safety is added when panic equals true, which happens when the monster is attacked. The only action that has get to safety as an after effect is run away. Run away makes the AI move away from where it got hit. If it sees a target and hunger is low enough, it adds the eat goal. The actions that have eat as an after effect are go to food and attack. The AI can run go to food if it can see food. However, it can run attack if it first runs either follow rat or follow, which follows the player. So this should make it so it goes to the closest target and then attacks or eats. However, since it doesn't replan after it's already made its plan, I had to add a function in the monster code which plans whenever it's chasing something and another target is closer than the one it is chasing. This is so the monster goes to the closest target. All the follow actions goes to their specific targets, and then once close enough, either deletes the target and then waits, or moves on to the attack action. The attack action kills rats and damages the player. After attacking, it stands still for 3 seconds. If hunger is low enough and it doesn't see a target, it adds find food as a goal. Find food is given as an after effect for wander and head to noise. Wander action is the same as the rat state wander. To do the head to noise action, it must first do the hear action. Once it hears a bomb, it stands still for 1 second and heads to the location. Wander will always cost more than hear and head to noise combined, so that going to noise is prioritized. I then added a check in the monster script that made it so once the monster heard a bomb, it would replan, so it would instantly head to the sound. At this point in development, I noticed a strange glitch that would happen. When my AI would walk up slopes, the frame rate would drop. This was due to the AI trying to use a node that was not walkable, so it would search through the entire grid trying to find a route. I fixed this by adding a function in the pathfinding script that finds the closest viable node. It was at this time I also added heap optimization to further reduce lag. I then started work on my robot behavior tree. I used the behavior tree scripts from 2D GameKit to make my behavior tree. The way the robot sees is through the overlap sphere, which once it overlaps, it does a raycast to make sure you can actually see the target. My behavior tree ended up mostly how I originally designed it. However, I had to add an extra condition as to make sure the robot was facing its target when attacking. It uses two pathfinding scripts, one main one which is used for the patrol path and the other used to follow the target and return to the patrol path. To find its patrol path, it uses RDA star pathfinding function that I made. When I first developed the RDA star pathfinder, I ran into a problem where it would take an incredibly long path. I fixed this by changing how I was working out the distance from Manhattan distance to Euclidean distance. The robot chases any target that gets near its patrol path. However, once they go far enough away, it continues patrolling. It attacks the monster, the rats, and the player. It patrols between a few locations on the map, and the reason why it uses RDA star is it does it once whenever it idles. It idles when it finishes its current patrol path. It was this time in development, while I was making the map, that I realized both the rat and the monster were struggling to get around corners, so I added wall detection to help the AIs get around corners. All AIs have relevant information displayed above them using widgets. The player plays the game using WASD to move and the mouse to look. To change what item it's using, the scroll wheel is used, and to use the item, left mouse button is used. The items that the player uses are the cheese, which can be used to distract the rat and monster, and the bomb, which can be used to scare away the rats. However, be careful, as it attracts the monster. The player starts with one each, and can get more by pressing E on the crates around the map. Looking back on what I've built, I've made several AIs that have different behaviors and different ways of thinking, and have done all I have planned, besides the group system that I planned for my rats. However, for improvements that I could do, is I could add more actions to my GURP system to increase the complexity of what action it chooses. Or I could add my rat group system that I was planning, where they would take each other's location into account when moving. Thank you for watching.